2 here, and welcome. So today's central question, how do you determine the relationship between two lines? Are they parallel? Are they coincident? Or are they intersecting? So those are kind of some diagrams as to what each is representing. Parallel lines never touch one another. Coincide, they are equal to one another. And intersecting, they intersect at one spot. So basically we're going to see each of those here. To review here, just a reminder, standard form of a line, ax plus by equals c. So you might already refer or know that, so it's fine. And just remember that a should not be negative, so no negative a value, and in general, no fractions, okay? So for these first few examples, it's really just rewriting in standard form. Feel free to skip over these if you feel comfortable from last time. But different ways we can do this, just remember we could subtract x from each side. So it's negative x plus 5y equals 17. We don't want it to be negative, so we multiply by a negative 1. Okay, and that just makes it x minus 5y equals 17. Negative 17, don't forget that. Okay, if you have a fraction, okay, there's different ways you can go about this as well. Multiplying by the greatest divisor, multiplying by the greatest denominator, the GCD, that can get rid of all the fractions. So greatest common denominator in this case is 2. If I multiply that through first, that will just set it up for me to properly write in standard form. That would be 8. And if we just move x over, x plus 2y equals 8. Okay, so really just getting you comfortable going back and forth between each here. For question 3, you might be saying, well, we can just multiply everything by a negative 2 to fix a few things at once. And that's going to make it x equals negative 8y minus 16, which would be x plus 8y equals negative 16. So that is just standard form in a nutshell. Let's see, did I multiply all those okay? I think so. Okay, so the real main idea for today, showing the relationship between two lines, okay? So basically some definitions here. Parallel lines have no points in common. They have the same slope, different y-intercepts. Different y-intercepts, okay? There's all sorts of parallel lines out there. So for example, let's show that these two lines are parallel, okay? To do that, we want to put them actually in slope-intercept form, so we're actually going to be going backwards. What we want to show is that they have the same slope, but different y-intercepts. So looking at them in slope-intercept form will help us out. So 2x plus 3y equals 6. That's the same as 3y equals negative 2x plus 6. Or y is equal to negative 2/3 x plus 2. Okay, solving for y. For line 2, 4x, so that's line 1. Line 2, if I simply subtract the 4x, so 6y is equal to negative 4x, divide by 6, we have y is equal to negative 4/6, which is 2/3. And notice here, they have the same slope and different y-intercepts. This one's at 2, and this one's essentially at 0. So that is our little proof that they are parallel, okay? Perpendicular lines, okay, they have opposite reciprocal slopes. Okay, opposite reciprocal, okay, which means if one slope is 1/2, its perpendicular is negative 2. over 1 opposite reciprocal. Okay, so let's show that these two are perpendicular. Again, it's all about writing them in slope-intercept form. So this is going to be 2y is equal to negative 3x plus 8. Okay, divide everything by 2. Y is equal to negative 3/2 x plus 4. That's line 1. Line 2, if we subtract 2x, we have negative 3y is equal to negative 2x plus 18. Divide by negative 3. We have y is equal to positive 2/3 x minus 18 over 3, 6. The fact that this is 2/3 and this is negative 3/2, sorry, that tells me they're perpendicular. They have to be both opposite and reciprocal. A little note. Okay, 3/2 is not perpendicular to 2/3. Okay, they intersect, but they're not perpendicular. So just because it's reciprocals, this one has to be opposite as well. Coincident lines, they have 2 points in common. They have the same slope and the same y-intercept. Basically, they're the same line. So coincident means they're the equal or the same. And usually what you'll notice is if we just look at these two equations, line 1 and line 2, notice how line 2 really, it's all factors of the first one here, are pretty similar. So let's just take a look and see what we get here. So actually, I think there's a little typo. We're going to make this 2x. How about that? 2x. Sorry for that little tweak. So by doing that, let's simply put it into y equals. So this is going to be negative y is equal to negative 2x with our little tweak there, plus 5, which means that y is equal to 2x minus 5. That's the real equation. For this one, we're going to have 2y is equal to positive 4x minus 10. If we divide by 2, we have y is equal to, hey, look at that, 2x minus 5. That's why I had to fix that. These two are the same equation, meaning they're coincident. Okay? If they have not the same slope and just 1 point in common, then we say they're intersecting lines. So they have 1 point in common, they simply have different slopes. Okay? If the slopes are different right off the bat, they are going to intersect. So pretty simple with this one. If we look at line 1, we have 3y is equal to negative 4x plus 9, and we have y is equal to negative 4/3 x. Divide by 3 plus 3. Second line's already equal to, or in slope-intercept form. So this is 2. This slope is negative 4/3. We know they intersect. Okay? Not perpendicular, they just intersect. So that's the main idea with types of lines. The only other challenging thing for today is creating equations that are parallel or perpendicular to other equations. Okay, and it's really a pretty simple concept, but students struggle with this stuff. So make sure you're practicing these and make sure you're paying attention with these here. So write the equation of the line that is parallel to negative 2x plus 7 passing through this point. We are going to use our point slope form. Okay, we have a point and we have a slope, we just need to figure out what slope should we use. So let's think. We want it to be parallel to this blue line. Okay? Well, the slope of that blue line is -2. Parallel lines have the same slope. Therefore, we want to use -2. So we reference this line, we reference the slope in order to use it. Once we do that, once you decide, it's really as easy as finding our point slope. So y minus -1 equals -2 x minus 5, and then just writing it in y plus 1, and we can leave it in slope intercept, that's fine, 2x plus 9. So they are parallel, and it passes through our given point. Similar for perpendicular, only this time when I reference the blue line, perpendicular, remember, have opposite and reciprocal. So if the original slope is -2, its perpendicular is going to be +1/2. Make sure you're making a note of that for perpendicular. So as we finish this one, it's y minus -1 equals +1/2, and then x minus 5, which means it's 1/2 x minus 5/2, and we'll subtract 1 from each side, and that just makes it y is equal to 1/2 x. Little shortcut with fractions, it's like taking 2/2, so -7/2, and that's it there. So these problems are the tricksters today. Make sure you're okay with perpendicular, and make sure you're okay with parallel, and there are some homework problems to try out for those. Okay, so great job with that stuff, guys. Good luck, and try out the practice problems.